Halt mich fest. Hello and welcome to another Solana tutorial. This is gonna be a short one because we're just gonna talk about how the system program creates durable nonces. In the last video we didn't figure that out, so I just wanna put that as an appendix or something. So let's look at that. So I found the source code for the system program, and by that I mean somebody showed me. Thank you, Elia Brunso. This is exactly what I was looking for, because I just found the program stuff like the Rust client-side stuff. But this Solana program's system source should be the right thing. Essentially, takes the account signers and invoke context. It must be writable. And here we see the state, because we also talked about that, where I wondered what that could be. Initialized or uninitialized. We do some more checks. The account must be a signer. So the data authority must be in signers. And there is the fun part. Next durable nonce is durable nonce from blockhash. If that is the same, then again error, nonce blockhash not expired. So yes, it does take that into account. It does take the recent blockhashes into account, but it's probably not an exact recent blockhash, but from a blockhash, derived from a blockhash somehow. And how? We will find that here in from blockhash. Source nonce state current has an implementation for durable nonce from blockhash, which takes the blockhash and returns a hash value, I guess, from a durable nonce hash prefix and the blockhash. Let's go back once more. Invoke context.blockhash. So that's the most recent one, I guess, that we get from that invoke, from this context. And then it's just, you know, like with a PDA derivation, several seeds, and the blockhash is one of them, and that seems to be a static seed, which is just durable nonce as bytes. Okay, so that makes sense why the durable nonce blockhashes, I don't find them in the list of recent blockhashes, but if I would hash it with durable nonce in the beginning and the blockhash, then I should find them. Is that enough for us, or do we want to double check if that's actually the case? Yeah, I have time. I'll spend a little bit. I'll spend like half an hour, because I want to, you know, I mean, reading source code is one thing, but then trying to figure it out by yourself, or like trying to prove it by yourself that you actually understood it. That's yet another thing, and I kind of like to do that, because I don't fully know what this hash actually does. Self.hash. Do we know what a Blake 3 is? Much faster than MD5. Okay, so it's just a hash function like SHA-3 or whatever. So I'm gonna do some defing and cut most of that out and then just give you the result. I'm just gonna read all the recent block hashes, calculate all the potential durable nonce hashes from that, and then see if one of them is the one that we get. That's my strategy now. So step 1, read all the block hashes. Can't be so difficult. Get account info for the block hashes, which is a buffer. Okay, now we need to know how those block hashes are stored in there. I just did that with slot hashes, which I assume is the same. I did it in Rust, but just to get the idea. First, it stores the number of hashes, the slot number, and then the actual. So I guess it might be similar. Let's try that if the block hashes has the same setup. The offset is info data read unsigned int 64 little endian. Why did I call it offset? Length. Ah, that's also a bad name. Number of block hashes. What's a good name for that? Count. No freaking idea. let's see if we get that far if we call recent block hashes. 150 block hashes. That sounds about right. Nice. Because I think 150 is exactly the number after which the block hash is expired. Right? After 150 block hashes, it's not in the recent block hashes anymore. So I think 150 makes perfect sense. Nice. I like it. So that's the amount, and then we just do a for loop for those 150. Each of them offset is 8 plus I times 8 plus 32, because we have a block number and a block hash. And then we read the block number like this with the offset. The block hash, essentially I can treat it like a public key. I'm gonna make a new public key. Was it slice? No, slice. Subarray. Offset plus 8 for the block number, and offset plus 8 plus 32. All right. And then I'm just gonna log those, see what we get if we do that. The way I could verify is that the block number would be sequential numbers. If I get sequential numbers for the block number, which I totally don't. So that now lets me assume that what I'm doing here is complete BS. Because I mean, yes, it looks like pub keys, but like it can be anything. That looks very much like random data. So damn it, that didn't work, unfortunately. If I would plug in the slot hash as pub key, yeah, there would be something. Okay, so turns out that the block hashes are stored differently than the slot hashes. Here I even have 512 slot hashes. Let's look at that. Slot hashes. What the Explorer shows me for slot hashes is slot and hash. Okay, what do you show me for block hashes? Block hashes. Oh, there's also the fee schedule somehow in there. Oh, damn it. And then there's just recency. So I don't think that that thing is encoded in there. Okay, we can use all our knowledge that we gained yesterday to figure out how big those fee calculator thingies are per block hash. Because I think that those fee calculator thingies are the same that are also stored in the nonce account. And the nonce account, if we remember from yesterday, was 80 bytes. A nonce account was 80 bytes. There. A nonce account was 80 bytes, and there were 2 U32s, 2 pub keys, and this fee calculator. So let's calculate something ourselves. We got a U32 plus a U32 plus a pub key plus a pub key. That's 72 bytes, which leaves 8 bytes remaining for the fee calculator. So a U64. So we might assume that the layout of the block hashes, first the block hash and then the fee schedule. So first the block hash is directly at the offset, and then fee, we don't really need to read that, but I want to read it to see if it's always the same, with offset plus 32, because it comes after the block hash. Let's see. So what I would now expect is that the fee schedule is always the same, maybe like 5K and then block hashes. Yes! Yes! Aha! I love it when my assumptions are correct, because that means it's now very likely that what we're getting here are actual block hashes and not just random data. That's cool. In fact, when we quickly also refresh those block hashes here, maybe we can then find one of them, or like a sol. That would be amazing. That's a cool block hash. Nope, that's already too old. We need to take a new one. The newest one here was FSZ. And yes, that we find. Nice. So we were able to actually fetch the proper block hashes. Cool. Okay, so far so good. We didn't really win anything from that yet, except we learned how the recent block hashes are stored in the Sysvar. And now we actually want to use this Blake 3 hash to hash ourselves potential durable nonces based off block hashes. Because that makes sense, right? We want it to be based on a block hash, but we don't want it to be the same as the block hash. That makes perfect sense. So just hashing it with another prefix is a good solution. Get durable nonce block hash, which is a pub key because it's just 32 bytes. It's not really a pub key, but the same way that a proof path is not a pub key, but the data structure pub key is basically just a buffer of 32 bytes. So that makes it nice to handle those things. Just so you know, it's not really a pub key. I mean, there could be a more general word for this, 32 bytes something something, but no. Pub key, then everybody knows what we're talking about. Anyway, so it takes the pub key and it calculates the Blake 3. So what do we need for that? npm I Blake 3. What? One of your dependencies are requesting a package version that doesn't exist. Oh, great. It won't let me install the module. I hate working with those dependencies. That's the pain of my existence. The bane of my existence? I don't know what you say. It sucks. Can't work around. I found is to use overrides in package JSON. Nice. Nice. Added 3 packages. Perfect. Let's see if we get some random hash. There we go. That's what I'm talking about. Just some hash from foo. And if I do the same thing with the same data, I'm gonna get the same hash. Cool. Now I just need to find the correct way to get the block hash into here. So first of all, prefix is durable nonce, I think. But let's look it up one more time because I don't want that to be my mistake. Durable underscore nonce. Good. I don't have types for this. That's annoying because I don't know what it takes. Can I put several things here? Yes, I can. I get a weird result, which probably means that means something else, that second prefix. That's possibly some size or whatever, because I essentially have zeros here in the beginning. So that's probably not what we want. So yeah, it does make sense to analyze the things that you're getting back and then make judgments about them. Do I have more like documentation on that? Data binary like and options length. Hehe, so it was the length. How many bytes do I need? Well, the length of that plus 32, so 9, 10, 11, 12, 13. 13 plus 32, and then buffer. Write the prefix as, what is that, UTF-8? SC would also be the same, but let's use UTF-8 because it's all just ST characters, and ST is a subset of UTF-8 as far as I know. Just the first 256 bytes. Is there a right public key? Set block hash to buffer, and my offset is 13. I mean, if that would work, right, on first try, then I would be highly surprised. We'll see. And then I see if I can plug in the buffer. So it will give me something, I guess, but will it actually be the thing that I'm expecting? I don't know. But yeah, we're getting something. I can put the buffer here in this Blake 3 hash. But okay, I mean, that's how I guess I need to build it. I'm fairly certain that I still have a mistake in there. So I don't expect that to work first try, but let's just try it anyway and see what happens. So let's not do a random hash anymore. Let's do one or several with the actual block hashes. So I'm not really interested in the fee schedule anymore. That's always 5K anyway. But we wanna log the durable nonce for this block hash. And that would then look something like this. For each of the block hashes, we get the candidates for the durable nonces. Looks kind of nice already. Look at those. All of the block hashes, all of the potential. Well, we don't know yet. It's just a random hash, but could be the potential nonce hashes. So to verify, let's get ourselves a new nonce. And I guess we can do that with CLI. Just need to check who owns my nonce right now. Bob still owns my nonce. Can I manually advance the nonce with CLI? Advancing the nonce or changing the nonce value? Het is my current nonce. And if I say Solana new nonce with Bob has the authority to change the nonces. And for some reason the transaction is not being confirmed. Send it again. That looks better. There we go. Now we have a CL5. And now if we quickly generate all the possibilities from... now we should potentially see a CL5 somewhere here. But I don't. Find this. Damn it. My guess is still that my hash is incorrect. And that's where it gets really difficult to debug now. Because I don't even know which block hash it really took. Or actually, do I know that? Does it always take the block hash? No, but no, it doesn't take the block hash that the transaction took. It takes the block hash from the recent block hashes Sysvar. Because here, I mean, I could check for this block hash, the CG, which is actually in there in my recent block hashes. And then DNC would be the result. But since it's taking the Sysvar of the recent block hashes, it's probably taking the first one from here. Because otherwise it could just, you know, take that and then it wouldn't need that. So I'm assuming that it takes another one. Okay, good, fair enough. How do we figure out what we're doing wrong? I said half an hour. I'm an hour in. I mean, I'm so invested now that I want to get this to work. Maybe we're not setting some bytes or something. So all of the bytes are being set, so that's cool. The first bytes are look very string-like, yes, because that's like in the range of like 40s and stuff. Well, 40 actually. That's hex, so it's 60s. Yeah, that actually makes more sense. Yeah, and that's always the same as well. So the prefix always the same, and then the rest is the buffer. I mean, I can print that as well. The block hash 2 bytes maybe. Oh, 2 bytes, that's integer array then. It's tough to compare. Yeah, that's stupid. Maybe make it to buffer. So E07, E07 until B5, So building my buffer works the way I intend it to. Question is if that thing then actually does the thing that I want it to do. The problem with hashes is as soon as something is even just a tiny bit off, maybe the other one is using some padding of some sort or something like that, then it's completely different hashes. That's why this is really hard to debug right now. And I don't know why I make it so important to actually figure it out, but I kind of want to figure it out. Oh wait, maybe I just made a wrong assumption in the very beginning of which hashing algorithm is actually used, because we have the SDK program source Blake3, which has the same name of a function, which doesn't actually mean that Blake3 is actually used here. Maybe that's why I'm going wrong, because there are many hash Vs. We are currently in... Wait, we are in the SDK though. But here it takes it from hash V. Hasher. Hasher is a SHA-256. Aha! I had a wrong assumption because I clicked on the wrong thing or just looked at the wrong thing. Something. Okay, so it's a SHA-256. Wouldn't have had to go through the trouble of this Blake 3 thingy. Let's rename that. Hashes. How do we do SHA-256 in TypeScript? Node.js comes with a built-in crypto module. Okay, perfect. Now let's just use that. Okay. A hash object. How do I get it out in a form that I like? Hex. I don't want it as hex. Can I have some docs on that method, please? Encoding. String. The encoding of the return value. Can you give like a little bit more detail what that encoding is? Ooh. If encoding is provided, a string will be returned. Otherwise, a buffer is returned. Yes! That's what I want! I just want the buffer. No encoding. Yes. Just dot digest. Give me the buffer. That was really hard to find out. That took me like over 10 minutes. That's looking better. Oh, that's looking great. We get the buffer. Nice! Love it. Okay. We get another try. We get another try of getting the hashes. This time SHA-256. Okay. So, let's get ourselves a new nonce. New nonce. Perfect. That's my nonce. And those are the hashes. So GSJ is what I'm looking for. Is there a GSJ somewhere in that list? GSJ! Bam! Oh, yeah! Look at that! We finally made it. It took us 1.5 hours to figure that out, but we figured it out. So that was the block hash that was taken into consideration, the 2BEK, and it creates this hash with the prefix of durable nonce. And that is then also what is stored in my nonce right now. Nice. We figured it out. Very niche thing to know. Like for most people, that's probably not very relevant. But for me, it was because I just want to learn how all those things work. And it's great if I find out. It's great if I just learn new stuff. I mean, I'm getting excited about that. And yes, I could have ended the video literally after 5 minutes when I read the source code. And I was like, okay, that's it. But actually building this thing and trying it myself is a whole other level of learning, right? It's the same thing as understanding a language and speaking a language, right? I mean, yes, I can understand, okay, this is how you build that hash. That's what goes in there. But then actually doing it yourself, actually speaking it, actually writing the code is a whole different story. That's so cool that I also managed that part, which is way more difficult. Way more difficult. Plus, also, we learned that it's not actually the Blake 3, but a SHA-56. If I wouldn't have tried it myself, I would also not have found that out, because I would have just gone with my initial assumption. But now I'm at the point where I can create the hash for the durable nonce based off a given block hash. It's literally just a SHA-256 that I create like that. That's it. And the code is that simple, but you gotta get there, right? Which, took me a bit more than an hour. So yeah, I hope that this video was informative for you as well. We now know how to get those durable nonces and what is actually in there. It's not really the block hash, but it kind of is the block hash. It's a derivation of a block hash. Nice. Oh, and one more thing that I want to check, the 2BEK is not the block hash from this one, right? The block hash from this transaction was 3K, so that's a different one. And then it took a recent block hash from the recent block hashes Sysvar. Nice. Well done, Bob. Man, I hope you learned something today. I did. I learned how those durable nonces are actually created. I've asked myself that the first time I made a video about durable nonces. I asked myself that the second time I made a video about durable nonces. And now, the third time we're talking about durable nonces, we just spent an entire video answering that question. How is a durable nonce actually created? Here, that's how. There you have it. Easy. I hope you enjoyed this video. Give it a like if you did. Subscribe if you haven't already. Turn a notification if you feel like being notified if my videos come out. And follow me on Twitter. I also post, hey, I made a new video there. So, yeah. Then I'll see you in the next video. It was a good deep dive, I feel. That was, you can't spend your afternoon like that. I'm motivated. I'm motivated to teach you as much as I can. Because mainly, I'm teaching myself. Mainly, I'm curious myself and I want to learn myself. And in the process, I might as well make videos because that motivates me to actually do it. Cool. I think next up I want to look into lookup tables. That could be also a very cool topic. Because my question is, can I change a lookup table after I've signed a transaction? So maybe I'll answer that in a bit. But first, I'll cool off because it is hot in here and I want to take a break. All right. See you next time. Thank you for watching. Bye-bye.